And here we go. Okay, so on Monday we talked a little bit about basics, about numbers and properties of numbers and properties of our basic operations of addition and multiplication and stuff like that. We went over some of the consequences of those properties of numbers, the different parts of the numbers, the count and the name, and how they react in our operations. And I realize that that's some pretty basic material, but I want to make sure we have those connections as we move into the other material. And today I wanted to start out by doing a quick review of integers. For the medical fields, we don't use a lot of algebra, but we do have to make sure we cover it. As I said, any of you that go on to a 4-year degree would have to take a college algebra and then probably statistics sequence. So we want to make sure that you're adequately prepared for those types of classes coming up. And integers play a big role in college algebra. So what integers are simply, what we talked about on Monday was all whole numbers, starting with 0, counting up to 5, and so on. Are just numbers without decimals or fractions in them. The integers include those whole numbers, but go the other direction as well, into the negative. -1, -2, -3, -4, -5, and so on. To represent a number on the number line, there's a couple of options. If I want to represent the number 6, I can just put a dot at 6. That works. But that's more of just a representation. It's not much of a usable definition or mechanical definition. The more usable definition or representation is to start at 0 and to draw a vector. And a vector is just a fancy word for an arrow that starts at 0 and goes to that number. A vector has magnitude and direction. It's positive because it starts at 0 and goes in the positive direction, and its magnitude is just its length. It's 6 units long. So that's a positive 6 is what that's represented. If we do an addition problem like 6 plus 2, the definition of addition deals with those vectors. So we take the vector, we've got the vector for 6 there. We take the vector for 2. Addition is telling us to take those two vectors, put them together to make one big vector. So what we now have is a vector that is 8 units long. And of course, we all knew that 6 plus 2 equals 8. We didn't need to draw out that picture for that. But where that comes in to help us now is with the integers. What if we have, instead of 6 plus 2, 6 plus a -2? So now -2 is represented like that, starting at 0, going to -2. And if we combine that with our 6, we can see that those vectors work against each other. We end up at 4. So we talked about direction and magnitude. I want to talk about absolute value for just a second. What absolute value is the length of the vector. An alternative definition of absolute value for a number is its distance from 0. Well, either one of those, whether we're measuring a length or whether we're measuring a distance from 0, are going to be positive. So absolute value symbol is just those vertical lines like that. That's the absolute value operator. The absolute value of -2, well, the vector for -2, as we saw, is 2 units long. So its absolute value is 2. So the absolute value is the length of that vector. So when we're looking at doing an addition here with integers, that absolute value, that length is important, and the direction is important when we're talking about those vectors. I don't draw out the number line like I did up here every time I do operations with these integers, but it does help to have that picture in the back of my head. For example, if I take 14 plus a negative 19. What I am thinking is this. Here's 0. Positive 14 goes that direction. Negative 19, it's negative, so it goes the opposite direction. And its length, it is longer because it has a larger absolute value. 19 is bigger than 14. So it goes the opposite direction, and it's longer, so that means it goes past 0. And what this little sketch is telling me is two things. One, we ended up on the negative side of 0, so my answer is negative. The second thing it's telling me is, since the vectors or the arrows go in opposite directions, the final value is the difference between those magnitudes, those absolute values. So the difference between 14 and 19 is 5. So my answer is a negative 5. So if I have a negative 27 plus 18, the same type of picture. Here's 0. Negative 27 goes right or left? Go ahead and just yell it out. You don't have to be shy. Left. Good. 18, they're going to go the same direction or the opposite direction? Opposite. Longer or shorter? Shorter. Very good. So what that is telling me now is we're staying on the negative side, so it's a negative answer. And again, the arrows go opposite direction, so it's the difference between the absolute values. The difference between 27 and 18 is 9, so it's a negative 9. We might have negative 15 plus a negative 36. So a similar issue. Here's 0. Negative 15 goes right or left? Left. Negative 36, same or opposite direction? Same direction. It really doesn't matter about the length because they're going the same direction. So this, because they're both going negative, the answer is obviously negative. Both arrows are going, both vectors are going the same direction. So we just add the absolute values, add the sizes. 15 and 36 make 51. So that's a negative 51. So now addition isn't so bad. Subtraction is where it gets a little trickier. Now we mentioned on Monday that subtraction really isn't its own operation. Subtraction is really defined through addition. And technically it's addition done in reverse. One of the definitions of subtraction, 5 minus 2 is defined to be what number plus 2 equals 5. That's one of the definitions of subtraction. We're going to look at another definition of subtraction here. Let's put this on the number line. If I were going to illustrate 5 minus 2 on the number line, I'd do it like this. Here's my vector for 5. Subtracting 2, I just go back 2 in the other direction. I end up at 3. 5 minus 2 is 3. We hopefully all knew that. But if we look at this picture here, that picture looks an awful lot like 5 plus a negative 2. This vector that we drew here is just the vector for negative 2. Well, in actuality, 5 minus 2 really is 5 plus a negative 2. This subtraction symbol always works, the operator always works on the number that comes after it. Subtracting 2 is really saying add the opposite of that number that follows it. So adding the opposite of 2 is adding a negative 2. Now 5 minus 2, if we just have two positive numbers, we've done enough subtraction that we can handle that. We don't need to deal with changing it over. It's when one of the numbers that we're working with is negative that there's an issue. For example, if we have a negative 18 minus 7. This is one of the easier ones with a negative in it, but still it's simpler if we change it over. So the first number never changes. Negative 18 will stay negative 18. It's the subtraction deals with the number that comes after the subtraction symbol. So subtracting 7 is going to be the same as adding, what's the opposite of 7? Negative 7. So that is negative 18 plus another negative 7. That comes out to be a negative 25. Probably the most confusing example of this might look like this. 24 minus a negative 13. So again, that first number is not changed. The 24 is just a 24, period. Minus a negative 13. Well, the subtraction here is plus, becomes plus the opposite of that number that follows it. The opposite of negative 13 is 13, the positive 13. So 24 minus a negative 13 is just 24 plus 13, or 37. We might have negative 18 minus negative 31. Now again, what happens to the negative 18? Nothing. It stays the same. Negative 18. Minus negative 31 becomes plus 31. Very good. So now if we're looking at this, we've got, here's negative 18. Positive 31 goes the opposite direction, and it's longer, so we go past 0. So that tells us our answer is positive, and the arrows go different directions, so it's the difference between 18 and 31, which is 13. So it's a positive 13. If we look at multiplication and division, let's start out with multiplication here. 5 times 3. We said on Monday, before we memorized our multiplication tables and we knew that 5 times 3 was 15. We figured that out by doing repeated addition. 5 plus 5 plus 5 is 15. 5 times 3 literally means take 3 5s and add them together. So with that definition in mind, negative 5 times 3 makes perfect sense. That's negative 5 plus negative 5 plus negative 5. So from 0 to negative 5, negative 5, negative 5, which is negative 15. Very good. If we have 5 times a negative 3, this is a little more confusing. Now, but we don't need the multiplication symbol. Now we can just do 5 and then parentheses negative 3. That means 5 times negative 3 as well. This is saying we're going to take 5 and add it to itself negative 3 times. That doesn't make any sense. Fortunately, multiplication is what we call commutative, which means we can switch the order of two numbers that we're multiplying. As long as we're just multiplying those two numbers, we can change our order. So instead of 5 times negative 3, we'll write that as negative 3 times 5. So now this is saying is take negative 3 and add it to itself 5 times. So negative 3 plus negative 3 plus negative 3 plus negative 3 plus negative 3, which of course is negative 15. Now I'm guessing you've all probably been taught this before. A negative times a positive is a negative. A positive times a negative is a negative. You just multiply the numbers without the signs, then use that to determine what sign the answer is. Well, here you can see why. It's because of that repeated addition that comes out that way. We've all also been taught that a negative times another negative has to be a positive. So negative 5 times negative 3 would be positive 15. Why? If we look at our definition of multiplication, I cannot take a negative 5 and add it to itself negative 3 times. Even if I change the order, I cannot take negative 3 and add it to itself negative 5 times. That doesn't make any sense. So technically, the definition of multiplication doesn't work for multiplying two negative numbers. So how do we come up with a positive 15 as our answer? Well, in math, there are several spots where our basic definition breaks down. So what we do is we look for a pattern with what we can do. Oops, my screen's going funny there. And then we define the result to be whatever makes that pattern continue to be true. So if I'm starting out, let's start out with negative 5 here and multiply by 3. We said negative 5 times 3 is a negative 15. So let's keep the negative 5 and change the 3 to a 2. What's negative 5 times 2? Negative 10. Good. Now if we keep going, the negative 5 we have to keep yet. We went from 3 to 2, so we got to go from 2 to 1. What's negative 5 times 1? Anything times 1 is itself, right? So negative 5. So if we look at what's happened here, so we're starting with negative 5 every time. What we're multiplying by, we're reducing by 1. We took 3 minus 1 gets 2. 2 minus 1 is 1. Let's look at our result here. Our result went from negative 15 up to negative 10. We added 5. From negative 10 up to negative 5, we added another 5. So the result is increasing by 5. So let's keep going. We have to start with negative 5 yet. If we reduce this by 1, what are we going to be multiplying by here? 0. And what's anything times 0, of course, is 0. So let's check our pattern. We still reduced this by 1. Did this go up by 5? It sure did. It went from negative 5 to 0. So that pattern is holding. So now let's keep going and see if that remains true. Well, actually, let's assume that the pattern is going to remain true and keep going. So if I reduce this by 1, 0 minus 1 is negative 1. Negative 5 times negative 1. Well, if I add 5, that has to be positive 5. Negative 5 times negative 2. Adding 5, that has to be positive 10. Negative 5 times negative 3. Adding 5, that has to be a positive 15. So you can see, even though our definition of multiplication doesn't work for multiplying two negatives, multiplying two negatives gives us a positive because it makes this pattern continue. It makes the pattern true. So when we are multiplying, obviously a positive times a positive is going to be a positive. A negative times a negative is going to be positive. So if we're multiplying two numbers that have the same sign, the result is positive. What if I multiply a negative times a positive? What do I get? Negative. Or a positive times a negative is also negative. Thank you. So I'm guessing we've all seen that before. And when we look at division, it follows the same pattern, but for maybe a different reason than what we've seen. The definition of division. On Monday, we looked at division as being repeated subtraction. 24 divided by 8 was asking us how many times can we subtract 8 from 24. That became 3 because we could subtract 8 3 times from 24. Well, today we're going to look at an alternative working definition, 24 divided by 8 equals blank, is asking us what number times 8 equals 24. Well, it's still 3. 3 times 8 is 24, so 24 divided by 8 is 3. If we look at it this way, though, negative 20 divided by 5 is going to equal. Well, that's asking us what number times 5 equals a negative 20. Well, we know, of course, that that has to be a 4. 4 times 5 is 20. The question is positive or negative? Has to be negative. For the 20 to be negative, since the 5 is positive, this has to be a negative 4 times positive 5 to give us a negative 20. Because a negative times a positive is a negative. So therefore, a negative divided by a positive has to give us a negative. If I have 18 divided by a negative 9, again, that's asking me what number times negative 9 equals 18. Well, we know it has to be a 2, but the 18 is positive. So for this result to be positive, these either have to both be positive or both negative. Since the 9 is negative, the 2 must be negative. So 18 divided by negative 9 is a negative 2. And finally, I might have negative 27 divided by a negative 3. Well, again, that's asking what number times a negative 3 equals a negative 27. Well, the 27 is negative, so for that to be negative, I have to multiply a positive and a negative. The 3 is already negative, so this number has to be positive. Positive 9. So because of that correlation with multiplication, when we divide, of course, a positive divided by a positive is always going to be positive. When we divide a negative divided by a negative, the result is still positive. A negative divided by a positive gives us a negative, and a positive divided by a negative gives us a negative. So, again, if we're working with two numbers that are the same sign when we multiply or divide, we're going to get a positive result. If they're different signs, we get a negative result. So which takes us to the next step, which is our next set of operations. All of our operations come in pairs. We have addition and subtraction. Adding and subtracting. Let's say, and we said that subtraction isn't its own operation. It's the reverse of addition. And here's what I mean by that. Let's say I start with 7, and I add 4 to it. What do I get? 11. There we go. If I want to take that 11 and get back to 7, what do I have to do? I have to subtract 4. So adding 4 and subtracting 4 cancel each other out. It's what we call inverses. Adding and subtracting are inverses of each other. The same is true with multiplication and division. Let's say I start out with, well, let's do 7 again. And this time I multiply by 4. I'm going to get 28. Now if I want to take that 28 and turn it back into a 7, I need to divide by 4, reverse it. So multiplying by 4 and dividing by 4 cancel each other out. Again, multiplication and division are inverses. Well, the next operation we're going to talk about is a power or an exponent. All right, we deal with our exponents or our powers. We'll look at that, its inverse in just a second. Let's say I have something like 8 to the third. What is that telling me to do? How do I calculate that? Perfect. 8 times 8 times 8. It's saying 3 eighths multiplied together. So that's 512. Do all of you know, is there anybody that does not know how to enter that in their calculator that wants me to go through it? Either have the caret key or the X to the Y key? Okay, perfect. So let's take a look at the opposite. What if I wanted to get from 512 back to 8? Well, the opposite of a power is a root. This here is called the index of the root, and this, notice it corresponds to the power that it is going to be the inverse of. So this is the third root of 512. Better take us back to 8, and it does. Now, many of your calculators have that capability. Some actually have a third root key on there. But for many of you, it's an X root, like that, or an N root, where you'd have to put the 3 in first, hit that root key, and then type in the 512 to get it to an 8. This clouds the waters just a little bit, however, when we throw in our integers. -9, let's go just go -9 squared for now. -9 squared is going to be what? -9 squared is -9 times -9, which is a positive 81. Now, some of you, when you go to punch that in your calculator might try to tell you it's a -81. We know that's not true. Why is your calculator trying to say that? Well, if you just do a -9 and then squared, or to the power of 2, what's happening there, and we're going to talk about order of operations next, one of the things coming up here. What's happening there is the power happens before the negative. So it's taking the 9 and squaring it and putting the negative in front of it. So it's taking the 9 and squaring it to 81 and then putting the negative in front of it. And that is not what we're looking for here. A negative times a negative has to be a positive. In fact, any number squared has to be a positive. Excuse me. So make sure, let me show you on my calculator here. If I did just -9 and I use the X squared key, it's going to try to tell me -81, and I know that's not correct. I have to do parentheses, -9, oops, come on, -9, close parentheses, and then squared. They'll give me that correct answer of 81. Now, because of that, what is the square root of 81? Well, the square root of 81 is asking us what number squared equals 81. Well, we know that 9 is the square root of 81. But there is a second answer. We just saw it right here. -9 squared could also give us 81. So whenever we do a square root, there are two possible answers. If I try to do the square root of a -25, though, what is our calculator going to tell us? Anybody try it? It gives us a nasty message. It says error. My calculator says non-real answer. What does that mean? Well, it's asking us what number squared equals a -25. We just said that any number squared has to be positive. Because a positive times a positive will be positive. A negative times a negative will be positive. There is no real number that we can square that'll give us a negative 25. Therefore, the square root of a negative 25 cannot be done with real numbers. Now, if you were to go on into a college algebra class, they would go on to define something called imaginary numbers that allow you to take the square root of a negative. We're not going to get into that in here. For our purposes, negatives cannot have a square root. Do not have a square root for what we're going to do. How about a third root, though? If I take negative 4 to the power of 3, negative 4 times negative 4 times negative 4, or, parentheses, negative 4 to the power of 3, I get negative 64. You can see there, I was able to get a negative answer with a third root. So if I go to take a third root of a negative 64, it's actually possible to do. Now on my calculator, to do a third root, I have to go through the math menu. So I go through the math menu, I'm going to select X root. So that's third root of negative 64. And it better spit back out my negative 4. Because here I did a third power and a third root. It better get me back to where I started, back to that negative 4. Let's look at a fourth power. Let's say I have negative 5 to the fourth power, which would be negative 5 times negative 5 times negative 5 times negative 5. If I work that out by hand, negative 5 times negative 5 gives me what? 25. Good. Now I take that 25 times the next negative 5, positive or negative? Negative, and 25 times 5 is 125. Now I have to multiply that negative 125 times the last negative 5, positive or negative? Positive, and 125 times 5 is 625. Negative 5 to the fourth power is a positive 625. So if I were to try to do a fourth root of a negative 625, is it going to work? No. Once again, the calculator is going to give us an error. Do we see a pattern of what's going on here with these negatives and powers and roots? Well, let's take a peek here. Negative 5 squared, is that going to be positive or negative? It's going to be a positive, 25, right? Anything squared must be positive. How about negative 5 to the third power, positive or negative? Negative, you got it, negative 125. Think of it this way. All I'm really doing there is taking negative 5 squared times another negative 5. Well, positive times a negative better give me a negative. How about negative 5 to the fourth? Positive or negative? Positive. Yeah, I'm multiplying by another negative, so it's going to be positive 625. How about negative 5 to the fifth? Positive or negative? Negative, that'll be negative 3,125. Then negative 5 to the sixth, positive or negative? Positive, good. Positive 15,625. The pattern here is, when will the result be positive? When the power is an even number. So, if we're starting with a negative number, no matter what happens, if we're taking it to an even power, we'll still get a positive answer. If we're starting with a negative number and we're going to an odd power, we will get a negative answer. So does that mean that this will be a negative answer? Because it's an odd power?
No.
So yeah, I'm going to say no. Because it's a positive number that we're starting with, it doesn't matter what power we're going to, it will be a positive answer. 7 to the power of 5 is going to be 16,807. Positive. No matter what the power is, we start with a positive number, it's going to be positive. So the consequence of this is the reverse, the roots. I can do a third root of a negative number because it's odd, and an odd power can give me a negative answer. I cannot do a fourth root of a negative number because a fourth root is even, and a fourth power will always give a positive answer. So there is no result, that no number that if I put it to a fourth power will give me a negative answer. So there is no fourth root of a negative number, so there is no even root of any negative number, only odd roots. Okay, well, our next step is to go into order of operations, and I'm going to stop there because we've only got about 4 minutes left. We did not have any homework on Monday. I realized I talked right up to the very end, so we didn't have any time to discuss homework. There was no homework for Monday. For Friday, I'm going to have you look at page 7 through 8, 1 through 59, the odds. Now, as I said on Monday, I do not collect the homework and grade it. This is there for your practice. I do recommend that you at least do some of them. Make sure you know what you're doing. Especially do the problems at the end, the word problems at the end, if there are any. Because those are the ones that most students will struggle with on our tests, are the word problems. And this course, as we progress on, becomes more and more word problems. Now, for the benefit of those of you in Medford that weren't here on Monday, your grade, as I mentioned, is completely based on your 5-unit tests. Those are 100 points each. So that's a total of 500 points for the class. Your homework is not graded, but it's highly recommended. The solutions to your homework are posted out there in Blackboard under that course informations button. All the solutions here, so you can check your answers, are in there, so you can click on those links and take a look at them. Also, for those tests, once you've completed a test, I will grade them and send them back to you. You can do corrections on those tests. You'll be able to redo the problems you got wrong and send them back and get up to half your points back. So if you struggle and you get an 80% on the test, you can redo them and send them back to me. I'll grade you back up to a 90%. We'll discuss that more when we get to the first test. So I just wanted to throw that out there so it's not quite so scary that you're only being graded on those tests. With that said, that's not a reason to skip the homework. Because like I said, the homework, the test problems are going to look a lot like the homework. And doing the homework problems are going to make you prepared for that. And it's really easy. I realize the first couple days here we're covering some very basic stuff that you've all seen before. But it's really easy as we get into more difficult stuff to be watching me do it in class thinking, that's easy, I got it. Very different when you sit down to do it yourself. So make sure you are at least doing a couple problems and skipping up to the more difficult ones and making sure you've done an assortment of the problems so that you're sure you know what you're doing. Okay, so with that, I will stop talking. That is your homework for Friday. I'll give you the last couple minutes to get started on those if you'd like. Anybody have any questions? Okay, well, I'm going to end the